Hey, I am Surendra Bhattarai. Today I am going to tell you about the power of light, especially radiation pressure. Can you say whether light can push things or not?
Definitely not.
Then you are wrong. It can push. Radiation pressure is the pressure which is exerted by electromagnetic wave. Imagine a cardboard being pushed by some small balls. These balls transfer their momentum to the board, as a result of which it is moved forward. In a similar way, a surface can be pushed by light. But unlike these balls, light is emitted in the form of small packets of energy called photons.
But photons don't have mass, so how can they have momentum?
This is the obvious question. But according to Einstein's special theory of relativity, energy equal to root over pc whole square plus mc square whole square, where m is the rest mass of the particle and p is the momentum. But rest mass of photon is 0, so from this equation we get energy equal to root over pc whole square plus 0, which finally equals E equal to pc. Therefore momentum equal to E by c. So if photons have energy, they should definitely have momentum. So we can say that an electromagnetic wave carries energy and momentum. In this equation, E is the total energy transferred to the surface, and the magnetic momentum transferred to the surface is P equal to E by c, where c is the speed of light in vacuum. From this equation we get force equal to change in momentum by time, which equals E by t by c, which further equals power by speed of light, which finally equals intensity into area by light. This is the force when the photons are absorbed. But when the photons are reflected back, the force gets doubled. Here we find that in order to get more force on the surface, we have to increase intensity of light and increase the surface area on which light falls. When sun shines on our hand, we feel the energy from its warmth. It also transfers momentum, but we do not feel the force, as c is very large from the equation. In 1903, two American scientists, Nichols and Hull, measured radiation pressure, which is about 7 micropascal. Based on this principle, NASA launched a small solar cell named NanoCell D in 2008. A LED cell or solar cell is a small spacecraft which consists of a very thin and very large sheet of highly reflective material that can be pushed by the pressure of light. Just like a sailing boat is pushed by wind, in the same way solar cell or light cell is propelled by photons coming from the sunlight. Unlike chemical rockets which need fuel, solar cells need no fuel. If you are using a rocket which uses fuel, you can only accelerate until you run out of fuel. But in solar cells, millions of photons can be captured per second, which will give you a constant acceleration. Larger you make the surface area of solar cell, more photons will be captured, and more you will get acceleration. It is estimated that in 3 years, a solar cell can reach a speed of 240,000 km per hour. At that speed, it could reach Pluto in 5 years, while it took NASA's Voyager spacecraft over 12 years to reach a similar distance. In future too, many breakthroughs are possible using solar cell, like discovering new planets, new stars, etc. So get ready for a bright future. It is also possible that in near future we would be able to carry objects with light.